Good morning to the lecturer. My name is Elvis Abadan. Today, I would like to present about the vehicle dynamic of case study DJA50082. So this is our code. So next is okay. This is our group member. So my name is Elvis Abadan, and the other is my group member. So next page is introduction of case study. This case study is part of the vehicle dynamic course, which focus on analyzing how a vehicle design and mechanical characteristic affect its performance, stability, and handling behavior. The project involved studying the Ford Ranger White Rock 3-liter V6 turbo diesels to understand the relationship between vehicle parameters and dynamic performance. The main objective of this project are to identify and evaluate key specifications such as vehicle weight, dimensions, transmission gears ratio, tire and suspension stiffness, turning radius, and tire rims detail. These parameters are essential in determining how the vehicle responds to force during acceleration, braking, and cornering. Through this study, the team aims to apply vehicle dynamics theories to a real-world examples, analyze the data obtained from manufacturers' brochures, and discuss how each specifications contribute to overall handling and stability of the vehicle. So, this is our objective of our case study. The objective of this project are implement access the most important element of vehicle dynamics to improve total performance and safety. This involves implementing dynamic Excel logs for understanding weight distribution when moving, examining driving and braking behavior to ensure stability, efficiency, and researching aerodynamic effects to minimize drag and enhance handling. In addition, the project also aims to estimate ride perception as comfort, make experimental understeer gradient measurements to identify steering behavior, and utilize cornering properties to optimize turning performance. So that's all for my slide. So I'm gonna mix pass my slide to the other groups.
Uh, Good morning. My name is Muhammad Sharul Nizam Azhar bin Johya. My matric number is 05AD 21F 2009. Today I am present for the process. For the first is vending, second test and analysis discussion, third conclusion, and the last is reference. Vending uh, about vehicle detail, weight, and dimension. For overall LWNH, for the L is 5370, for the weight is 1918, and for the H is 1884 mm. Wheelbase 3270 mm. For the track is FNR 1620 mm. For the ground clearance is 230 mm. Uh, Overall cargo bed LWNH is for the L 1564, and for the weight is 1584, and for the H 540 mm. Cap weight 2280 kg, and grass weight 3300 kg. Water weighting is 800 mm. Full tank is 80 liter. Transmission gear ratio data and 10-speed automatic. Tire and suspension stiffness data. For the front, double weight band with coil spring. For the rear is leaf spring. Vehicle turning radius 1.12.9 m. Tire and rim detail is 255 per DJA50082 tire on only rim. Uh, Test and analysis. Figure out the load distance on the axle with the vehicle acceleration from standing start up and uphill route at 3.7 meter per second. Assuming the CG height is 0.5 meter. That's all from me. Thank you.
My name is Jaren. I'll be presenting the 3.0 task analysis. So for task 1, we are required to figure out the load distribution on the axle when the vehicle accelerates from a standing start up at 4% uphill road at an acceleration of 3.7 meter per second square, assuming the center gravity height is 0.5 meter. To solve this question, we have to use the formula of dynamic load transfer during acceleration. Before applying all the information to the formula, we have to know the information that is required to solve the question. So firstly, we know that the wheelbase of our vehicle is 3.27 meter and the mass of the vehicle is 2,280 kg. So first step is to convert the percentage of the uphill into degree, which is 2.29 degree using tangent. And with all the information, we just have to sub in into the formula and we can find out the answer easily. So task 2, we are required to determine the vehicle first until 4 gear tractive force. So to find out the answer, we have to use the formula of tractive force. So in this situation, the torque and the torque and the efficiency of the tractive of the gear is constant, and also the tire radius, which is 0.395. So with all the information, the only difference is the gear ratio. So for the first gear, we have the gear ratio of 4.696. The second gear ratio is 2.985. Third gear ratio is 2.146. And the gear 4 is 1.769. So from gear 1 to 4, it's obviously the bigger the gear, the smaller the gear ratio. So with all this information, we just have to sub in into the formula of tractive force, and we can find out the force that produced it from the gear easily. So next is the tractive limited acceleration if the coefficient of friction is 0.62. So to solve this question, firstly, we will use the maximum force, maximum tractive force, which is the total force, the total force at front side and rear side multiplied with the coefficient of friction, which is 0.62, and with the answer, we just have to sub into the formula of limited acceleration, the formula of traction limited acceleration, and we can find out our acceleration easily, which is 6.08 meter per second square. The task 4 is to use the tire calculator to find out the stiff rate of our tire, and A, the front and rear axle rate, and B, the front and rear axle natural frequency in Hz. So we have to sub in the correct information of tire into the tire data calculator, and to find out the stiff rate of our tire is 26.1 kg/millimeter. With the information, we just have to convert it into Newton/m. So the answer will be 258493.5. And with this answer, we just have to sub in into our rack rate formula so that we can find out the right rear at front and rear axle. Next, we have to find out the natural frequency. So we just have to sub in the, firstly, we have to know the distribution of weight of our vehicle. At the front side is 52%, and the rear side will be 48%. With that given, we just have to multiply the percentage of our weight distribution to our weight so that we can find out the actual weight of the front side and also rear side. With that, we can easily find out the natural frequency using the information that we have. Task 5 will be using an Ackermann geometry illustration and to determine the vehicle inside and outside steer angle. Firstly, we have to sketch the illustration of our geometry as is also sketched by me. You can see that we have to find out the inside steer angle and also outside steer angle. So how do we find this? As actually using the formula of Ackermann geometry and Ackermann steering geometry, and you can find out the degree of the steer angle.
Number 6 is spread down the advantage and disadvantage of tire change based on a review of a tire specification. Starting with the advantage, wider tires have more rubber in contact with the road, which improves traction and control, especially during turning or braking. Lower profile tires flex less, making the steering feel sharper and more responsive. This wider tire also provide more balance and stability at high speed, and they make the car look sportier and more powerful. However, there are also a disadvantage. Wider tire create more rolling resistance, which means the engine must work harder and use more fuel. Thinner sidewall make the ride bumper and then absorb less shock from the road. The steering can feel heavier, and the speed meter reading might be inaccurate due to the new size. Finally, bigger tires are more expensive and can wear out faster, especially with aggressive driving. Alright, the next slide is about discussion. From the calculation, the Ford Ranger Wildtrak 3.0 V6 turbo diesel demonstrate good balancing and performance. When the vehicle accelerates, more load shift to the rear axle, which help improve traction and grip. The tractive force results show the vehicle can accelerate smoothly without losing stability. The suspension analysis indicate that the neutral frequency is around 0.92 Hz, meaning it turns more for comfort rather than sporty handling. The Ackermann steering geometry ensures the front tire turns smoothly without sliding. The tire and aerodynamic review confirm that wider tire give better grip and cornering ability, but they also make the rider rather and reduce fuel efficiency. This shows the vehicle dynamic always become comfort, grip, and efficiently. Next is about practical recommendation. Based on the finding, here are some practical recommendations to improve the vehicle performance and handling. Add an underbody cover or rear spoiler to reduce air drag and improve stability. Improve airflow under the car for better fuel efficiency. Use adjustable shock absorber to switch between comfort and sport mode. Slightly increase spring swiftness for better control when cornering. Choose lower rolling resistance tire for better fuel economy. If more grip is needed, use slightly wider tire without changing the overall diameter. And lastly, always maintain the correct tire pressure to ensure safety and handling. In conclusion, the study showed that the Ford Ranger Wildtrak delivers strong performance, good traction, and a comfortable ride. The load, traction, and steering analysis confirm that the vehicle is well balanced for both city and off-road driving. With small design improvement, such as better aerodynamic, stiffer suspension, and improved tire, the Ranger can achieve even greater stability, comfort, and fuel efficiency, making it safer and more enjoyable to drive. This is the reference. Finally, these are the reference used in this study, which include data and review from Pautang, the Sun Malaysia, Ford Malaysia. This source provide verified information about vehicle performance, specification, and tire dynamic that support our analysis. Alright, that's all for us. Thank you.